This meeting is being recorded.
In this next section of the Chapter 16 worksheet on acid-base equilibria, we're going to take a look at some other, in quotations here, we have P scale. So what I mean by that is that when we talk about the pH, sometimes referred to as the power of hydrogen, we are asked here to take the negative base 10 logarithm of the quantity, in this case, hydronium ion concentration, right? So that's what pH tells us. But there are other relationships and assumptions that we can make using similar comparison. So for example, right, let's start off our list here with pH. And we can put below that, if we wanted to find POH, we know that that's going to be the negative log of, you guessed it, hydroxide ion concentration. Then we have the water autoionization constant here. If we want to find that, we could take the negative log of Kw. If we wanted to find pKa, for example, that's our a way of ranking weak acids. Instead of a pH scale, we use the pKa scale. We'll take the negative log of the Ka, the acid dissociation constant. We could do the same thing to find pKb, another more convenient way to rank weak bases, and then we'll take the negative log of Kb. Next, we could do the inverse or the reciprocal of these functions. These are other useful relationships to think about for this chapter. So 10 to the negative pH, that will give us the hydronium ion concentration. 10 to the negative POH, like so, will give us hydroxide ion concentration. So if you're given one or the other, you can utilize these types of relationships and kind of reverse the log function here. So like so, 10 to the negative pKw gives you Kw. We can do all of our pKa, gives me Ka. 10 to the negative pKb gives me Kb. And again, all of these equations may come in handy from time to time if you're only given certain pieces of information. So let's take a look at sample exercise 6 here. And we're told that a solution is formed by dissolving an antacid tablet, and we calculate our pH here to be, or found our pH to be, 9.18. So we're asked to find, through the relationships above, the hydroxide ion concentration. So we know from previous video that pH plus POH will equal 14. So we can rearrange this relationship. If we know pH, we can plug that in. So we can end up subtracting that from both sides. So then our POH would simply be 14 minus 9.18, and that gives us a POH of 4.82. So now you may be wondering, what can we do with this information? Using this relationship right here that we just wrote down, we can find the hydroxide ion concentration by raising this value 10 to the negative 4.82. And that's going to give us approximately 1.5 times 10 to the negative fifth molar for our hydroxide ion concentration.